Today, I am excited to talk about one of my favorite topics, and that is verifying dimensions for trusses. I'm Chad Johnson. I've worked in the truss industry for over 30 years, and let's get started. The first thing that we'll need to talk about is what sort of access will a truss technician need when they come out to your job site. And this is pretty simple. They'll need to be able to verify that the large truck that will be bringing the trusses in can get from the street to the job, and that there aren't any overhead obstructions such as power lines or tree branches, that the driveway is wide enough and it doesn't have any sharp turns that would prevent a truck from getting around them. Once they verify that the access is adequate, then they'll take a look at what needs to be measured. If it's a brand new build, then they'll pretty much just need access to the foundation, or if the framing has started, that framing, in order to verify that the dimensions that we have in our design match the dimensions that are on the job site and nothing was misinterpreted along the way. So there are a couple of key differences between measuring to match existing versus new construction. So when we're matching existing construction, we have to make sure that our roof pitches, heel heights, overhangs, and many other conditions are going to match the dimensions that are on site. Whereas if it's new construction, we can just make sure that the foundation, the floor, whatever framing is in place matches the plans that we are working with and how we interpreted them. So one of the key aspects of getting a new truss to fit either new construction or existing is to make sure that we start out with the right span. So let's talk about what does span mean and a couple of different ways that it can be measured. Our measurement for span is from the outside of bearing to the outside of bearing. Now, that measurement that we're taking is to the framing. So sometimes people will look at the bearing and include the sheathing material that's on the outside of the wall, but we don't want to count that when we're measuring our span. Now that's a typical scenario where the truss bottom cord ends at the outside of the bearing, so we don't want to confuse span and length, because span and length are two different things. So there are different kinds of truss heels, which if you want to learn a little bit more about those, we talked about them in an earlier video. We'll put a link in the notes. But a cantilevered overhang is where the end of the truss goes beyond the bearing point, and so the span would be from outside of bearing to outside of bearing, but the length would be from the end of the truss to the end of the truss. Sometimes there might also be an overhang beyond the end of the truss, even with a cantilever, but that's something that the plans should show, and if it's existing that we're matching, we would check for that while we're on site. Okay, so we talked about span a little bit versus length, both very important, and also a cantilever versus a standard overhang. Now, when we are doing new construction, those details are typically spelled out in the plans, but when we're matching up to existing, we'll need to see every part of the existing framing that we are matching up to. So imagine that we come out to a job site and here's the end of the house and it's all covered with siding. Well, there are a bunch of assumptions that we would need to make in order to match. So for one, what does that truss look like where it sits at the outside wall? It could be that the wall comes up into that enclosed soffit and the truss goes around it. It also could be that the top of the wall is at that lower soffit level. And so in order to determine the heel height, which we'll get into in just a moment, we need to be able to see the framing at that point. That means that the siding will need to be taken off of there, and if there's any soffit material, that will need to be removed as well. In case you're not sure what soffit is, that's the siding that goes on the underside of the overhang. So we'll need to be able to see that heel. Also, we'll need to be able to take a measurement from the peak of the truss down to the bottom of the truss. And so that bottom of the truss might be up here, the bottom of the truss might be down here. Either way, we need to expose the framing in that area so that we can see where the bottom of the existing truss is or the stick framing. Also, that should be the same spot as the top of the wall. And we'll need to expose this portion of the truss up here at the peak so that we can find out exactly where the top of that truss is. Now, we don't only need to get those 3 spots, we need to get both ends of the truss because it's possible that the framing configuration is not the same on both sides. The heel is what we refer to as the portion of the truss that is sitting over the outside of the wall. And so what I've drawn here is what we would call a standard truss heel. And that's where the top chord of the truss essentially sits right on the bottom chord, and it looks something like that. Now we can't tell that it looks like that unless we remove any siding off of that end. Once we get the siding off, we may find that it's a standard heel like this, whether it's a 2x4 or 2x6 or whatever they used, but it could be many other configurations. So there are cases where we have what we call a raised heel, and a raised heel is generally built so that we can get deeper insulation out to the end of the truss, but in order to match that existing framing with new, we would need to know exactly how tall that truss is or that framing at the outside of the wall. The only way to tell that is to remove any siding off of that and get a measurement from the top of the wall to the top of the framing or the top of the truss. Back to our standard heel, the same would be true if we were trying to match it. We would need to get a measurement from the top of the wall to the top of the truss at the outside of the wall. And that's what we refer to as our heel height. Now, something that comes up very often when we are matching existing framing is that framing might have been framed on site out of rafters, in which case it might be, let's say, a 2x8 rafter, and what the framer did in order to get that 2x4 overhang is they did what we call a bird's mouth. The bird's mouth is a cut around the bearing, and if we can't see what's there, then we can't match the existing framing. Additionally, there are times when this might be a 2x4 or a 2x6, and because of this bird's mouth cut, this dimension is less than 3.5 inches. If that dimension is less than 3.5 inches, roughly, then we're not going to be able to put an overhang on our truss because a 2x4 won't go across that wall. In that case, there are a few options. We can build our truss to match whatever the height out there is, and then on site, the framer can add an overhang. They can sister it onto the side of the truss. Another option is we may take the new framing and lower the walls just a little bit so that we can get that height down to where it needs to be so that a 2x4 can cross over that wall all in one piece. In addition to knowing exactly how the truss is framed or the stick framing is done at the outside of the wall, this is also where our roof slope starts. And so having that portion exposed allows us to take a measurement to figure out what the roof slope is. Okay, so let's talk about one of the very important aspects of any truss package, and that is the pitch. Now, when we talk about pitch, we talk about the amount of rise in 12 inches of run. So standard terminology for a roof pitch might be a 4 in 12 or a 5 in 12 or a 6 in 12. And what they're referring to is how many inches does it rise in a 12-inch span. So in order to have our truss meet the correct point up at the top, we need to have it sloping properly. And so we will take a measurement of the slope. Now, the best way to get that measurement is to expose the truss at the bottom, at each end, and at the top, and then run a string line or use a laser level and figure out exactly how tall that truss is from the very top to the very bottom in the center, and how tall that truss is from the very bottom to the very top at each end. That makes it very easy to calculate the slope. Now, sometimes due to obstacles, such as maybe there's a bump out in the roof or something like that, it can be difficult to get that measurement all the way across. So the way that we would do it is we would use a level. So let's say that this is our truss top chord, and this is the top of our heel right here. So what we can do is we can put a level against that truss, and the longer the level, the better. This level I'm using in this case is a 2-foot long level, and so we can set it at level, and we can mark where the end of that point is, and then we can take a plumb measurement to the top of our truss. And this needs to be done, I'm doing it kind of quickly, but it needs to be done very accurately. And so if we know our horizontal distance, so that's 2 feet, and we know our vertical distance, in this case, that's 15 inches. Actually, it's important to be very accurate. It's 14 and 13/16. Now, that may sound like a higher level of detail than we would want to get to, but keep in mind, if we're off on that measurement by a 1/16 of an inch and we project it out 15 feet, well, that would be an inch of difference by the time we got up to that top. So with those two pieces of information, we can get out a calculator such as a Construction Master, and we can do some quick math. So for instance, here's a Construction Master app that I have on my phone. It's very helpful. Now I can punch in there 2 feet of run, 14 and 3/16 inches of rise, and then I can push the pitch button, and it tells me that that is a 7 1/8 12. Now, to be even more accurate for my truss designer, I'm going to convert that to a decimal, and it's 7.09375, which I would round to 7.094. So that is super specific. That's 7.094. And that will, having that level of detail will ensure that our truss technician can get a large truss within a very small fraction of exact accuracy to the existing framing when we build it new in our factory. Additionally, like we were talking about, we would want to know exactly what is this height out at the bearing, and in this case it is 4 1/4 inches. So by passing on that information, 4 1/4 inches and the 7.094, then we can make sure that this slope will match the existing framing. So let's talk a little bit about overhang on trusses. Like we mentioned, there are a couple of different kinds. One is an open rafter, another is an enclosed soffit, where the bearing is in from the end of the truss versus being at the very end of the bottom chord. So if we have an open rafter, then this is going to be a single piece of lumber, whether it's a 2x4, 2x6, or 2x8. So in that case, if it's new construction, we're going to want to limit our overhang length, which is measured in inches from the outside of the bearing to the end of the truss. We're going to want to limit it to a dimension that the lumber will perform well in. And so In our typical 25-pound snow load area, which covers most of low-lying western Washington, if we're doing a 2x4 top cord, we would want to limit that overhang length to 3 feet or less. And the reason for that is two. One, if you're working on that overhang, it's going to feel very spongy if we get longer than 3 feet with a 2x4. And then two, over time, that lumber will be susceptible to what we call creep, and that means that it will start to sag and it will become noticeable. So we limit the length of the overhang based on the depth of that top cord. So if it's a 2x6 top cord, we can go longer than 3 feet. If it's a 2x8, even longer. So that covers an open soffit. Now, if we're talking about an enclosed soffit, we could go 1/3 of the truss length, 1/2 of the truss span. And there's kind of a rule of thumb when it comes to cantilevering, and that is twice as much of the truss needs to be inside the building as what can be outside the building. Okay, let's get into the nitty-gritty now, because when we come out to measure, or if you're measuring to match an existing framing, there are so many different profiles that the existing framing could have. But we'll talk about a few of the basics. So first off, we have our common truss, and with our common truss, like we talked about, we're going to need to know where those bearings are. So we'll need a measurement from the outside of bearing to the outside of bearing without including the sheathing, just the framing. And so that common truss is going to look something like this here. And so we'll need to measure outside of bearing to outside of bearing. We're also going to want to measure from each end to the center to make sure that that peak is in the middle. Now, usually it is, but especially with stick framing, that peak could be off by an inch or a few inches. And if that truss is built symmetrical, then we're going to have a problem aligning that end. So how far is it from each end to center? Another measurement that we're going to need is the overall height. And the overall height is from the ceiling or the level of the bearing of the truss up to the very peak. So once we've got those, we also need that heel height that we talked about, and that is the measurement from the top of the bearing to the top of the truss or the top of the stick framing at the outside of the wall. And then we'll want to know what size is our top cord. Is it a 2x4, 6, 8? Are we matching the tail on that? Finally, we'll want to know what is our overhang length in inches. And so the heel height will be in inches, the overhang length will be in inches, the span or length will be in feet, and the height will be in feet. So as we look at this, you can tell that it would not be possible for us to match existing framing. So this would be like going up to the gable of a common house. It would not be possible to match that existing framing unless we can get access to all of these points in order to take a measurement. Otherwise, we would be guessing, and since everything is very unique, there's a high likelihood that stuff wouldn't fit if we didn't get those measurements. So that's what we need on a common truss. Okay, at this point, before we move on to the next type of truss that we would measure, let's cover a common concern, and that is, hey, I'm exposing my house to the elements by removing all of this siding. Well, that is true. So it's a good idea to be prepared before your truss technician comes out to have some visqueen or some Tyvek or some sort of vapor barrier that you can put over those areas after we do our measuring. Generally, it's not a problem long term because all of these areas are going to be exposed in the construction process anyhow. It's just necessary for us to get those areas exposed a little bit ahead of time so that we can get those accurate measurements. With the siding off of there, we're going to use our tape measure and we're going to get all of these measurements. We may use a plumb bob, we may use a string level, but whatever method we're using, it's just very important that we can actually see the framing in order to get those measurements accurately. So just like pretty much every other type of truss that we might take measurements for, if we're going to match up to a truss with a vaulted ceiling, we're going to need to know the same information. What is our height from the peak of the ceiling to the peak of the truss? What is the height from the bearing point to the peak of that ceiling? And then, of course, on this one, we would need to know how far is it from each side to the center of that vault. So a little bit more to expose. Sometimes we can get this information from inside the house, if it's a vaulted ceiling, that sort of thing. But at the end, we'll still need all of that stuff exposed. Now, probably the simplest to measure for is what we would call a monoslope truss or a single slope truss. And just like it would imply, it just has a slope on one side. So we're going to need to expose the heel of the truss so that we can get a vertical measurement at the heel. We'll need to be able to get the measurement at the overhang. We'll need to expose the top of the truss and the bottom at the tall end so that we can get those measurements at the tall end as well. And then we'll need to get the measurement from bearing to bearing, or the bottom chord length of the truss. With all of those measurements, we can determine what that pitch is, or if we need to, we can use that level like we talked about. Another typical style of framing that we'll match up to is what we call a porch truss. And that is a case where we've got a shallow slope on the outside, and then it gets steeper. And this is often used to cover up a porch without making the truss a whole lot, or the framing a whole lot taller than it is to start out with. Now, when we have that style of truss, just like any other, we need to be able to verify every single point of measurement on that truss. So in this case, we would need to expose the end of the truss out here so that we could get, or the stick framing, so we could get that vertical measurement at the end. We can get an overhang length out at the overhang on the truss. We would need a length from the bottom, the end of the bottom of the truss on the outside to where the bearing is. Then we would need a length from bearing to bearing. If the end of the truss on this side stops at the bearing, then that would be the last bottom chord length we would need. And then we would also need the overhang length on that side. If it was a cantilevered truss, we would still need that length as well. Now we're going to need the heel height at the other end of the truss from the porch, and then where the truss crosses the bearing on the inside where the porch is, we'll need that height as well. Now we're getting into some real critical measurements as well. We're going to need to know the height where this, we call it a pitch break, where the pitch changes. So real common, maybe this is a 3/12 and this is a 7/12, just for an example. So we need to know, where does that pitch break change both vertically, and also we need to know horizontally, where is that pitch break. Then we're going to need to know horizontally where the pitch break is to where the ridge is, and we're going to need to know from the outside of the bearing to the ridge on that side as well. Just like the common truss, we're going to need a height from the very top of the truss to the top of the bearings, where the ceiling is, and then if we can get it, it's very helpful to get an overall length of the truss. So a gambrel truss is going to look maybe something like this. It's got a bunch of different pitch breaks, and we need to know where every single one of those is in order to match. So that means that we're going to need to expose the heel, we're going to need to expose each pitch break, the peak, and then we're going to need to take measurements to each of those points. we'll take horizontal measurements, we'll take vertical measurements at each of these points all the way across, and then of course we'll get our overall length. So without going into a whole bunch more detail on that, it's just important that we get into each one of those points. We can see exactly what we're trying to match. Sometimes we'll use plumb bobs in order to get these horizontal measurements. But in the end, as long as we get all of the measurements that we need, we can match up to that truss very accurately. When we're matching up to existing, there are a couple of different building shapes that may impact how we measure that are separate from the shape of the truss. So one type of match that we would need to do, we've been talking about this primarily, but it's where we're matching up to the gable end of the building, which is essentially the end of the house where the siding just keeps going all the way up to the top of the truss. So when we're matching a gable end, we have to be super accurate about every dimension. Otherwise, something's going to be off. The slope might not match, the heel height might not match, the peak might not match, unless we get those accurate dimensions. Now when we match up to a house that's more of a T shape, so if you think of our gable as our house is coming along here like this, looking from the top, and we're adding on like this, that would be matching onto the gable. If we're going to do an addition where we're matching on as a T style, then maybe this is our existing and this is our new addition out here, and so we're going to have what we call a valley that will make the transition from one part of the existing house to the new addition. When this is the case, it's a little bit less critical that our dimensions be exact, not unimportant, but if you think of it this way, if this is the side of our roof, and here's our gutter, and here's the house below it, and now we're adding on this addition here that's going to match up like this. If the roof slope is a little bit different, it's not as critical. If the heel height is a little bit different, not quite as critical, because if this doesn't match this slope here, well, it'll just be tied in. So a T-style match is a little bit less demanding than matching up with the end of a building at a gable. In addition to not exposing enough of the existing framing, another common pitfall that I see when someone is measuring to match existing is they'll use something like the handy dandy speed square that we've always got in our bags, and it's very readily available and it's great for making shortcuts. But if we use it for something like the pitch on a truss, let's say, we put our level up on the top, make sure that we get it just right, and then we come down here and we say, oh, that's an 8.5 12 on my speed square. Well, that's fantastic, except that the 8.5, well, actually, that's actually a 9 in between the 8 and the 10. So that can be misread pretty easily. But the biggest thing is it's just such a short sampling, such a short distance from our pivot point to where we're taking our measurement. So let's say that we get that nice and level. We take our 8.5 12 or 9 12, and so we figure, okay, it's a 9 12, no big deal. When in reality, it was just a little bit closer to the 8, so it's actually an 8 3/4 12. Well, what that would mean is that if our point is here and we project that up to the peak, for every foot that we get away from that point, it would be a 1/4 inch difference. If we get 4 feet away from that peak, then we're going to have an inch of difference between the top of the existing framing and the new framing. So These are good for a whole lot of different things, but they're not good for measuring to match trusses to existing framing. That's why I always like to recommend that we use a level. The longer the level, the better. A 2-foot has worked out well for me over the years, but it requires that we be very careful and precise, measuring down to the 16th of an inch. If you can get a 4-foot level or a 6-foot level, that's better. The best way is to measure all the way to the peak of the truss if you're able, and take that measurement. If you're unable to get all the way to the peak, then if you can come over 12 feet, then you can get a very accurate vertical measurement, which converts nicely over to the inches in 12. If you measure up 7 feet and across 12 feet, then that's a 7/12, 7 inches and 12 inches, or 7 feet and 12 feet. So probably the biggest pitfall, like I said, aside from not exposing enough to get the dimensions, is just taking too short a measurement, because just like a golf ball that you hit a little bit at an odd angle, or a baseball, when you hit that, it starts out real close, but the further it gets away from where it starts, the further off it goes. Well, we sure did cover a lot today. Certainly don't want to make it seem overwhelming, because it's really a matter of just taking enough measurements and getting that information to your truss technician, or if your truss technician comes out to take the measurements, having enough exposed that they can get the measurements that they need. Some other things that might be necessary is to have a ladder on site, have a helper on site. We certainly don't want to take these measurements on our own without someone else out there to work with us. And it's not necessary in every case, especially with new construction. It's typically very simple for the builder or the homeowner to just make sure that the dimensions that are on site match the plans, and confirm for the truss technician that, yep, it's the way that it is designed. If it is a scenario where things are a little bit complicated, we can always come out. There may be an additional fee involved, but any fee that you would pay in order to get a site visit and a measure is going to be much less than replacing trusses, or modifying trusses, or modifying your building in order to match some trusses that didn't match the existing perfectly. So I hope this video has been very helpful for you. I've certainly enjoyed it. Probably my favorite part of being in the truss industry is going out to job sites, meeting with people, and solving problems. And definitely matching up to an existing building is a problem to solve, but it is very solvable. We do it all the time. If you would like to have a little more information on how to measure for existing trusses, up here is a link to a video where I did a site visit, and so you can take a look at what it looks like in the field. And then down here is a link to our remodel truss sheet, and that looks like this right here, and it shows you all of the dimensions that you would need to fill in and share with your truss technician for a typical common truss. Thanks again for watching.